Welcome to this lesson on radical expressions. A radical expression is an expression that uses a root, like a square root or a cubed root. And the radical symbol looks like this. The radicand is the number inside the radical symbol. So this is my radical symbol and this is my radicand. If you want to simplify a radical expression, that means you're going to be breaking down the radicand so that it has no perfect square factors. So for example, if I wanted to simplify the square root of 12, I'm going to try to find the largest perfect square that will divide evenly into this number. So it may help if you list out the perfect squares. You don't need one because one will go into every number, but starting with 2 squared, which is 4, I'm just going to list them out right over here. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. That's probably all we need for simplifying. So I want to look at the number 12 and I want to try to find the biggest number out of this list that will divide evenly into 12. So really the only number that's going to divide into 12 is 4. So I can rewrite the square root of 12 as the square root of 4 times the square root of, 4 times 3 will give me 12. So I just broke it down into two numbers, 4 times 3, because that multiplies to give me 12. And I wanted to use 4 because it's a perfect square. So what that allows me to do, now I can take the square root of 4, which is 2. And then I'm just going to leave the square root of 3 because it's not a perfect square. I can't simplify it. And then I can simply write that as 2 square root of 3, or 2 root 3. So this is the simplified version of the square root of 12. Okay, let's try a few more of these. Okay, so we have 18, so I want to look back at my list up here. The largest perfect square that will divide evenly into 18 is 9. So the square root of 9 times the square root of 2, because 9 times 2 is 18. And then I can take the square root of 9, which is 3, and I'm just going to leave the square root of 2. So 3 root 2, or 3 on the square root of 2. All right, let's look at the square root of 7. So I'm going to look at my list and see if any of these numbers will divide evenly into 7. And none of these numbers will divide, which means the square root of 7 is already in simplest form. I can't simplify it any further. So not all radical expressions can be simplified further. Sometimes they are already simplified as far as they will go. Okay, number 3 is a little bit different because it has a negative out front. I'm just going to not worry about the negative right now and just worry about 24. So I'm going to look at my list. The biggest number that will divide evenly into 24 is going to be 4. And 4 times 6 is 24. Then I'm going to take the square root of 4, that's 2. And then I'm just going to bring that negative down and apply it to my answer. All right, the next one, the square root of 40. So let's see, the biggest perfect square that will divide evenly into 40, that's going to be 4. So the square root of 4 times the square root of 10, because 4 times 10 is 40. So that's going to give me 2 on the square root of 10 as my simplified answer. All right, number 5, the biggest perfect square. Well, actually 16 is a perfect square. So if I want to simplify the square root of 16, I just take the square root, and that is 4. All right, now we have a number being multiplied by the radical expression. So similar to what I did here with the negative on number 3, I'm just going to bring the 2 down at the end, and I'm just going to simplify the square root of 8 first. So the biggest number, perfect square, that will go into 8 evenly is 4. And if you want to go ahead and bring down 2 in this step, you can. So this is my 2 times, and then I broke down the square root of 8 into the square root of 4 times the square root of 2. Okay, now I'm going to take the square root of 4, which is 2, and then bring everything else down. So I can multiply the 2 numbers on the outside, 2 times 2, that gives me 4, and then just bring down my square root of 2. So 4 square roots of 2. Okay, pause the video now and see if you can complete 7 through 12 by yourself. All right, let's see how we did. So the next one is 56, so I want to see which perfect square can divide evenly into 56. And if you're not sure if it's a larger number, just take your calculator and start dividing. 56 divided by 4, 56 divided by 9, 56 divided by 16, until you get one that divides evenly. And 4 is the only number that's going to divide evenly into 56. So the square root of 4 times the square root of 14, because 4 times 14 is 56. So that's going to give me 2 root 14. All right, for 80, let's see, 16 will actually go into 80, divide into 80 evenly. And if you want to go ahead and bring that negative down, you can. It's really a negative 1 multiplied by the radical expression. So I have negative 1 times 4 times the square root of 5, which is negative 4 on the square root of 5. Okay, 28. The biggest number that will go into 28 evenly is 4. So I'm going to bring this 4 down. And then 28 can be broken down into square root of 4 times the square root of 7. Square root of 4 is 2. So that would be 8 square root of 7. All right, 68. 4 will divide evenly into 68. And 4 times 17 gives me 68. So that's going to be 2 square root of 17. All right, number 11, we have 6 on the square root of 25. Well, 25 is a perfect square, so it's really 6 times 5, because the square root of 25 is 5, which gives me 30. All right, and then the last one, we know that 9 will go into 18, so I'm going to bring my 3 down. The square root of 18 is the square root of 9 times the square root of 2. The square root of 9 is 3. So 3 times 3 is 9 on the square root of 2. Okay, let's talk about operations with radical expressions. So you can add or subtract radical expressions if they have the same radicand, which remember is the number inside the radical symbol, the square root symbol or the cubed root symbol. All right, so let's look at these examples. So number 1 is the square root of 3 plus the square root of 3. We can add those together because they have the same radicand, which is 3. And when you add those, you're going to get 2 square roots of 3. So you can think about it as a 1 times the square root of 3, so 1 plus 1 is 2, and then you bring the square root of 3 down. So you're really adding or subtracting the number outside of your radical symbol. Okay, number 2, 5 square roots of 2 minus 2 square roots of 2. Because they have the same radicand, I can subtract those. And I'm going to subtract the number outside the radical symbol. So 5 minus 2 is 3 square roots of 2. All right, number 3, 6 square roots of 3 minus 2 square roots of 5. Those do not have the same radicand, so I cannot subtract those. So the simplest form is that. You can just leave it like that. That's as simple as you can go. And then number 4, the square root of 12 plus the square root of 3. So those are not the same radicand, but I can actually simplify the square root of 12 like we learned in these notes up here. So remember, I want to find the largest square root that can go into 12, the largest perfect square, which would be 4. So that's going to give me 2 square roots of 3 plus square root of 3. So now they do have the same radicand of 3. And remember, there's an understood 1 being multiplied by the square root of 3. So this would simplify to 3 square roots of 3. That would be the final sum. All right, so multiplying radical expressions. When you multiply radicals, you multiply the radicands. So square root of 2 times square root of 3. I'm just going to multiply the numbers inside to give me a square root of 6. Number 2, square root of 2 times square root of 2, that's square root of 4. And then always make sure you simplify all the way down. The square root of 4, that's a perfect square, so 2. All right, number 3, 4 square roots of 3 times the square root of 5. So when you have numbers outside of the radical symbol, you multiply those together as well. So this is an understood 1 being multiplied by the square root of 5. So I'm going to multiply 4 times 1, which gives me 4. And then 3 times 5, that's square root of 15. All right, and then the last one, square root of 12 times square root of 6. So I'm going to multiply those. Square root of 36. And that is a perfect square, which is 6. Okay, let's try a few more together. So number 1, I have 3 plus the square root of 2. Now, when you have a number and you add it to a radical expression, they don't combine into one number. You actually can't combine them. Because 3 does not have a radical symbol, but the square root of 2 does, they are not like terms, so you can't simplify that any further. It's just 3 plus the square root of 2. That's all you can do with that expression. All right, number 2, we're multiplying here, so we're going to multiply the radicands. So 7 times 4, that's the square root of 28. And then you always want to simplify. So I want to find the biggest perfect square that can go into square root of 28. Now, let's think about this for a second. If you look back to this step, it's really already done for us. The square root of 7 times the square root of 4, well, the square root of 4 is a perfect square. So instead of multiplying 7 and 4 together, let's go ahead and simplify the square root of 4 first. We know that is 2. So we have the square root of 7 times 2. And then we can rewrite that as 2 on the square root of 7. And that's a little bit quicker. All right, number 3, we have 3 square roots of 6 plus 7 square roots of 6. They have the same radicand, so I can add the numbers on the outside. So 3 plus 7 is 10 on the square root of 6. All right, number 4, those both have the same radicand of 5, so I can subtract the numbers on the outside. So 4 minus 9, that's negative 5, times the square root of 5, or on the square root of 5. All right, number 4, I'm multiplying here. Let me make sure I can't simplify any perfect squares first. Neither of those are a perfect square, so I'm just going to multiply them together. 2 times 8, that's 16. And 16 is a perfect square, so my final answer would be 4. All right, number 6, 5 minus the square root of 3. This is similar to number 1 because 5 does not have a radical symbol. It's not a radical expression, but 3 does. So these are not terms that we can combine. So all we can do is just leave it like that. That is as simple as we can make that expression. Okay, pause the video now and try 7 through 12 by yourself. All right, let's see how we did. All right, number 7, those are both radical expressions, but I cannot add them together because they don't have the same radicand. So this is as simple as I can make it. All right, number 8, 3 times 32. So I can multiply those together. Now, because 32 is a larger number, you may want to go ahead and simplify that first, because when I multiply 32 times 3, I get 96. That's a pretty large number to simplify. You can do it that way if you want, but I'm going to go ahead and simplify 32 first. So I want to see what perfect square will divide evenly into 32, and that would be 16. And if you want, you can just go ahead and bring all of this down. So the square root of 16, that's 4. All right, so now I can multiply the two radical expressions, the square root of 3 times the square root of 2, that's the square root of 6, and just put my 4 on the outside, 4 multiplied by the square root of 6. Okay, number 9. I'm adding here, but those do not have the same radicand, but those are pretty large numbers, so I can probably simplify them and see if they do have the same radicand when they are simplified. So let's see, 28, the largest perfect square that will go into 28 is 4. 4 times the square root of 7, so that gives me 2 square roots of 7. And then the largest perfect square that will go into 63 would be 9. 9 times 7. So that would be 3 on the square root of 7. And remember, I'm adding here. So now they do have the same radicand, so I can combine them together. So that's going to be 5 square roots of 7. All right, number 10. So I'm going to multiply the numbers on the outside and then also the radicands. So 2 times 3, that's 6. 2 times 5, that's 10. Make sure we can simplify that. Square root of 10, that's as simple as I can go. So that's my final answer. All right, number 11, I have 3 square roots of 5 minus square root of 45. They don't have the same radicand, but let's see if I can simplify the square root of 45. So let's see, I know 9 will go into 45. 9 times 5, which gives me 3 square roots of 5. Let me bring this down. So I brought that down here, brought my subtraction sign down. So now I have 3 square roots of 5 minus 3 square roots of 5. Well, that's 0. All right, and then number 12. Let's see. 18, square root of 18 times 2 square roots of 3. I'm going to simplify 18 first. So that would be 3 square roots of 2 times 2 square roots of 3, which gives me 6, 3 times 2 on the outside, and then on the square root of 6. Oops. Okay, you can stop the video now and complete the practice.